Hello, everyone. Well, today we're going to be chatting through basically the difference between decentralized and centralized compute. But before we dive right in, I would love to, obviously allow everyone the chance to introduce themselves. Just briefly on myself, I'm a partner with Framework Ventures. We're an early stage venture firm focused entirely on crypto and predominantly looking to be lead or co-leads in seed and in Series A's, focusing on just about every category in crypto at this point. I joke we're basically generalists, but of course AI is one of those categories. But yeah, I would love to go down the line and just allow everyone a chance to introduce themselves and tell us a bit about what you're building and what your team is up to. Start with you, Mikhail.
Hello everyone, I'm Mitra, I'm co-founder and CTO at Spheron. We are building a decentralized GPU supercomputer network where we are aggregating from both data center grade GPUs as well as your retail grade GPUs. So we kind of launched two kind of nodes. One is for the providers, one is for the community. Community nodes can be run on any kind of device, your gaming laptops, your Mac, and it's kind of going pretty well. We have almost had like more than 8,000 nodes in the network and more than 2,000 plus GPUs in the network. So kind of scaling that up as well as working on the UX side of things to make it easier for everyone to use the GPU and deploy some AI workloads.
Hey everyone, I'm Matthew. I'm one of the co-founders of OpenGradient. We're building an end-to-end decentralized platform for AI model hosting, secure inference, agentic reasoning, and application deployment. And what that actually means is we allow developers to build powerful AI workflows directly in smart contracts on our platform that they can integrate into their decentralized applications, both securely and seamlessly. So they can build agents, they can build modeling workflows that take raw data, process them, feed them through a model for inference, use them for making features of their applications more optimized or more intelligent, working with a lot of DeFi protocols to introduce things such as risk management, making vaults more effective, and covering a large range of use cases.
Hi everyone, it's a pleasure to be here. My name is Jeremy. I'm leading business operations at Hyperbolic. So at Hyperbolic, we're building decentralized AI infrastructure with a mission to actually democratize access to AI. We're focalizing on three core goals. So goal number one being the GPU orchestration layer. Goal number two being the verification layer, so making sure that we can have a verified, trusted, network, especially when we're talking about like third-party nodes that are contributing, compute. And then third, the privacy layer. So going back on the two core products that we've been building, the first one is a GPU marketplace. So we are making it possible for suppliers of compute to actually share, for now, in a permissioned way, but we're opening up very, very soon in a permissionless way, compute. For that, we created our own operating system called HyperDOS, which is short for Hyperbolic Distributed Operating System, and basically allowing them to connect very easily to our network and then serve it to the people who need it the most. So, AI developers, researchers, AI startups, and so on and so forth. And then eventually we're focalizing on the AI services layer. So we've been working on providing, inference. So we're hosting open source AI models like, Llama 3 or Flux or, Stable Diffusion, optimizing those models and making sure that we can serve it again to the people who need it the most.
Hey everyone, and thanks for sticking with us. I know you might be stuck because of the rain, but thank you for being here anyways. I'm Mikhail with Prodia. I'm the founder of Prodia, and what we do is we have a high-performance inference network, right? We specialize in media. Right now, specifically with images and video, we're the second company in the world to host open-sourced video. And we basically just make a very simple-to-use REST API to implement media into your app, and all the distributed and decentralized stuff is abstracted away.
Beautiful. Well, gentlemen, in the sake of time, would love to just dive right into it. Curious to get your thoughts, given that you're all experts in various domains of AI and compute, and there's a lot of nuances to it, but just at a high level, we'd be keen to get your thoughts on what is sort of the ideal future for compute infrastructure. Of course, we're talking about centralized or decentralized, but is one or the other better than one? Is it best to perhaps think of a hybrid sort of architecture moving forward? And of course, just to clarify, centralized refers to a lot of kind of, boxes and data centers owned by big tech, monopolies, so to speak, whereas decentralized is more broadly characterized as more of kind of an edge compute paradigm or distributed resources. But yeah, I would love to turn it over to the panel and just hear your thoughts as to what is the ideal architecture generally for these compute resources moving forward?
I think it's kind of a way you can like architect the whole thing. Like the main base layer should be completely decentralized, like the compute and the GPU and those base layer where you actually do the deployment. It should be permissionless. It should be completely on-chain so that anyone can join, anyone can use it, and shouldn't be some single centralized entity controlling everything from the supply side so that you doesn't have access to it. But on top of it, there are a lot of different tools, right, like which are important for kind of businesses to work, like monitoring systems. There are like important verification stuff, which they use to like make sure that their application layer doesn't cause any kind of problem due to like some outages and stuff. So I think those are some important thing which can be kind of a service layer but centralized so that it can make sure the decentralized part, the permissionless compute layer can be fully utilized and can give like better experience for the user, and we can like grow towards like Web 2 world as well.
I think asking what the ideal architecture for compute, whether it's decentralized or centralized in the future, is kind of like asking what the ideal car to drive is. And it just like depends on requirements, right? There's no like ideal car you should drive. Like if you're a racer, yeah, sure, maybe in like a Ferrari or a Lambo or whatever the state of the art is for that kind of stuff. If you have a family, maybe it's a Volkswagen van, right? Similarly, for compute, it does depend on just what your requirements are. Your requirements around privacy, around the sensitivity of the data, around verifiability, fault tolerance, liveness. These are all important considerations that you have to factor into kind of your kind of like SLA when it comes to choosing what the correct paradigm of compute is. And I will say, ultimately, I believe there will be use cases that will be predominantly focused on centralized compute, and also vice versa. It just really does depend on what you want to get out of it.
Yeah, I think that's actually a very, very good point. I highly agree on that. The way I see it is that, as you mentioned, it depends on the use case. It depends on what the clients and what the user, the end user, is looking for. I do believe that decentralization comes with a cost, and it's basically having a verification mechanism for third-party nodes that you don't know. So this is a problem that we've been trying to take very, very seriously, because if we want to actually promise all the advantages of decentralization, including obviously, a much more affordable cost to compute, because the problem with centralization, for those of you, I'm sure a lot of you know this, but like, GCP and Azure and AWS, unfortunately, are practicing very, very high margins, and they're totally entitled to do so because they have clients that are willing to pay for that. The advantages of decentralization is that you can actually aggregate idle GPUs from all around the world and actually offer it to the real, researchers and developers and young AI startups that really need it. So this is a real advantage for these three, I would say, verticals. And again, it really comes with this cost of verifiability, because the advantage of Amazon and GCP and Azure is that they're relying on two things. They're relying on signing legal contracts and reputation. So, that will entitle them to actually make sure that the end user is going to be happy with the compute and make sure that it's the actual compute that is being used for what they're looking for. On our end, we are trying to basically, finalize and set up this verification piece. And so for that, we created a new solution called proof of sampling. So there are existing solutions for this, like OPML, ZKML, Consensus, but none of them are really practical for the applications of AI. And so this is the reason why we created this. I'd be happy to dig a little bit more in the future around those details. Or if you have questions, you can ask me later. Yeah, I would say that's my take.
I agree with it depends, and I know it's a really crappy answer, but maybe I can redeem myself with simplifying the difference. Centralized, you get performance. Decentralized, you get censorship resistance and cost savings.
Right. And, I may not have a PhD, but I know the answer is almost always it depends, especially asking general questions like this. But maybe we could, double click for a moment into particular maybe applications or workloads or even industries. And yeah, I would love to, come back to the panel with just maybe we can highlight where our industry and more of kind of the decentralized, distributed, edge-like mentality, what are some of the applications you're seeing or building yourselves that make the most sense versus, frankly, where should we not be trying to compete with centralized and big tech just because, frankly, they just have big guns, right? They have resources, they have capital, they have talent, sort of the regulatory stuff as well. We don't need to go down the laundry list, but if you were to chat with a founder after this panel and sort of direct them in a particular application category, what have you, what would you generally tell them?
For us, specializing in media and performance, we're not fully decentralized, we're distributed, right? And the reason for that is we're a high-performance network. The largest consumer apps in the world are powered by us. And what that means is they need really, really low latency. And as we get more permissive over time, more use cases open up. But at the moment, our focus has been kind of on the performance side, on the image side. And video, the reason why there's only like a handful of people who can even do video outside of us, right, is because of the big requirements and the interconnect required for that, which is extremely, extremely difficult in a fully decentralized system. So, the use cases you start to see pop up on the kind of, when you go more towards the decentralized route, is something that's not time sensitive, like batch jobs, right? That's kind of what we've seen come up on our side.
Yeah, I think it's worthwhile to outline just a couple core key advantages of decentralization over centralization and using that as a guideline to decide what type of solution you want to employ, right? So, as alluded to previously by Jeremy and Mikhail here, there are some advantages, including, censorship resistant. That one's pretty obvious. I think secondly is, cost as well that Jeremy talked about, taking advantage of idle GPUs or compute hardware that you can aggregate now and create this service that wraps around it. But I think thirdly, one that was a bit less touched on that I think is also valuable is there are actually potentially performance benefits to decentralization. And while centralized machines will always be beefier and be able to compute, over more data, they have, you can't outcompete data centers when it comes to hardware. But there are optimizations to decentralized networks around, as an example, co-location or especially, edge compute, where kind of if it's lightweight compute and the network latency or overhead actually outweighs the kind of the performance benefit that you get from a cheap hardware to state-of-the-art hardware, there can actually be benefits there, right? So again, I think it really does depend on evaluating what you need and the type of compute you're trying to do, and then looking at these use cases and deciding what makes sense.
Can I say something controversial?
Please.
We started with that hypothesis, and we disproved it. We thought having nodes at the edge was going to overtake the kind of latency requirements, but it's just, given how much RAM these models are starting to require, specifically for media, that ended up being false for us. So we couldn't get the decentralization performance upgrades, and that is why we had to stick with distributed.
I know. I definitely agree with that, especially when it comes to media. The compute's probably rather expensive.
Yeah.
And I think Edge also comes with, I think
and bandwidth of a video. Do you know what the bandwidth of a video takes?
Yeah, no, I absolutely totally see that. I guess I wouldn't classify that as like lightweight compute.
Yes.
But you also get, as an example, like privacy around your data. You don't need to think about like type things such as FHE if the model is on your local device, right? And
I have a question about that for you, if that's all right.
yeah,
Can
I mean, I'm
ask-
not an FHE expert, but go ahead. Yeah.
Where would decentralized for kind of low compute versus self-hosting win? So that's where I've had a kind of a mental block where I couldn't figure out if privacy is so important to you, why don't you just self-host? And especially if it's low compute requirement. And that is where I was trying to figure out, and what again, one of the things we couldn't solve is where does this start to make sense?
Yeah, so as an example, by the way, like I don't work on edge compute or any of this.
Sorry.
But my personal take is, as an example, like if you have like some health device that tracks your biometric data and then it does some type of compute that isn't crazy, might be some like fast Fourier transforms, and then like look at the data for erratic health behavior. I think that's an example of somewhat lightweight compute that would also make sense for you to host on your device because it's lightweight enough and it keeps all of your data private, right? I think that's just like one example to your point. Again, I'm not an expert on
Did
any of this.
not mean to grill you.
No, but I think that's there are definitely more niche use cases. I think in the case of Prodia, if you guys are doing video generation, you guys have huge bandwidth requirements, especially when it comes to generating longer form video content. I think definitely makes sense.
It's not long form yet. It's 5-second videos.
Okay. Like regardless, I imagine it takes a good amount of compute to get the job done.
Only 4 H100s.
That's it. Light. Well, I think, Matt, you brought up kind of an interesting word, privacy, right? I think in the spirit of kind of either proving or disproving theses or theories, one that's often kind of quoted or referred to in the broader crypto or decentralized compute industry is one of, hey, look, we're going to have better data sovereignty, enhanced sort of privacy measures and performance around all of that. And basically, we're going to ride new regulations into this, golden era utopia-like, civilization where everyone cares about privacy and we can, have it offered on our local devices, essentially. And, I would love to just sort of maybe stress test that and have you guys go down the line and offer your thoughts on, obviously, it's a nuanced topic, but is this something that's actually true and has legs to it? Or does decentralized kind of meet the privacy requirements that everyone sort of needs at this point?
Yeah, I can maybe start on that point. So as I was explaining really briefly earlier, like the third core goal that Hyperbolic is working on is actually privacy. And we decided to focus on privacy because let's take a general example. So let's say that actually I'm a compute provider on the network and that someone here in the audience is actually a user on Hyperbolic. You might actually have sensitive data that you don't necessarily want to share to a third-party node. You don't know me, you don't know where I am, you don't know, what I can do with your data. And so that is the reason why we were thinking that, it's extremely important to make sure that we can provide this privacy level for multiple use cases. I gave an example of like you as a user. It can also be enterprise, data that can be very sensitive. We all know like, financial data being very sensitive and health data, et cetera, et cetera. So for that reason, we decided there are multiple solutions. We decided to go with trusted executed environments because we think that it's much more practical. The good thing with confidential computing in a way is that it's already existing on the H100 machines, which is, something that we can utilize and make sure to, offer it for a very, compelling, I would say, use case as I was explaining before. And the good news is that NVIDIA actually confirmed that they're going to be implementing this in all of their machines, whether it's consumer grade or enterprise grade. So in other words, it's not going to be a premium anymore that we're going to be offering at a very high price. It's something that we can offer literally with any NVIDIA compute in the future. It's going to be implemented very soon. And the actual overhead on specific use case, for instance, inference, is just 0.1%. So we really believe that it's not going to be tackling much in terms of performances, and at the same time, it can really offer this layer, especially for sensitive data.
Yeah, no, Jeremy took a lot of the words straight out of my mouth. Very, very excited about kind of NVIDIA's confidential computing solutions. As for OpenGradient, we have basically two main solutions that we go about with privacy. So one is similar to Hyperbolic, using trust and execution environments to provide guarantees around privacy. The second one is leveraging ZKML. So that's to keep models that are typically more lightweight, private, and there are settings where you can use different commitment settings that can keep either the input, the output, or the model weights private. So it really just, again, kind of goes back to the use case that you're trying to build for. You can have different types of use cases, leverage different types of solutions. One thing I'll also add into the mix that we've been kind of building out is the data access level. Obviously, to build powerful AI workflows, they need to be data-rich applications that are able to access different sources of data that you can then compute over. And in machine learning, we have this saying called like garbage in, garbage out, right? It's like data is very, very important. And so we have also TLS certificate level security for NTEs for accessing data that you can then feed into some arbitrary workflow, such as inference-driven workflow. And there's like a very popular library that we're using. It's like nitriding, and we've been incorporating that into like nitro enclaves as an initial kind of use case that we're proving out with early launch partners. So the AI workflow can really be secured end to end. And also, while maintaining privacy requirements around the data as well.
Yeah, so I have a different take. Privacy doesn't matter. And I know. I'll be more specific. Privacy doesn't matter with generative media. So there's two things we discovered to be true. The value of generative media trends towards zero because it's getting cheaper and cheaper to compute. But also privacy doesn't matter, and I'll tell you why. And here's where I really learned it. I'll give you guys a quick story. When we started our pilot with a large social media company, we thought this was going to be a huge issue. Like, oh my God, we got GPUs everywhere. They trust us. And what we discovered is they're like, yeah, we don't care. We'll just put in the terms of service that your prompts aren't private. Like, who cares? You're generating something new. What do you want to keep private, right? And we're like, I guess that makes sense. Privacy doesn't matter.
What do you have to hide? Exactly.
No. If you have something to hide, we'll block it with our filters, right? But that they tune. But privacy didn't matter.
Okay. Hot take. You heard it here first. I think just with the remaining time, would love to go down the line and just think out loud as to, frankly, what are some of the brick walls we need to break through? What are some of the barriers with respect to the adoption of all the things that you're building? And there's multiple vectors or parameters to kind of think through. It could simply be the tech itself. It could be economics. It could be simply user preferences, or even just familiarity with these options or these alternatives. But yeah, writ large, what are some of the main things to think through as it relates to friction that you guys are encountering, and how we can just overcome that?
I think one of the factor that kind of like restrict people from using like decentralized, which is like a reliability factor of compute providers and like GPU providers, which is very, very annoying because like everyone just comes to decentralized, kind of like all the UX is kind of getting better and better, and so they can use it, but when they go and try it out and like after deploying something, it doesn't work. It kind of like completely breaks their morale, and they went off to use AWS again. So I think we need more better solutions there. We need better way to like verify if the GPU is working properly, or a monitoring system, or a verification monitoring system, which can say like, okay, this GPU is already like it gives challenges to that, and then kind of makes sure that okay, it is always running. And we kind of did the same thing with our like compute providers. we kind of created a tiering system with the economic incentive on it, which kind of like restrict these providers from like thinking, okay, if they when they get better and better with their challenges, they went up to the tier, but if they do something wrong, they go down, which caused them to like think, okay, we need to fix this before we go down and lose our incentive. So we kind of did that, and I think it's quite working. So I think we need similar solutions or maybe more innovation in that sector, which we are kind of doing. And let's see like how we can make more better, reliable, decentralized compute and provide it to every user and even Web2 peoples.
I know we're running a little bit short on time, so I'll try to keep this, quick. I would say tooling. Up until now, like with the advent of TEs and ZKML, we now can incorporate ARML workflows into replicated state machines, i.e., blockchains securely. But a lot of the tooling hasn't caught up yet, right? We don't have kind of tooling that could help build, verifiable data preprocessing, agentic reasoning, feature encoding. All of these things need to exist in order for us to build like powerful workflows that can then be injected into decentralized applications to introduce this like whole new design space. And one of the things that we're working on is we're building all this tooling directly on our network so people can build AI workflows directly into their smart contract and build powerful stuff. So yeah, that's one big problem we're tackling and something we're excited to continue to be building.
Yeah, also, I know we're out of time, but like really briefly, I think it's a bunch, it's two things. I think the first focus is around UX, UI, making sure that we have very easy processes, both on the supply side and on the demand side, making sure that it's extremely easy for any compute provider to actually share their compute on a decentralized network, and making it extremely easy for the demand side to actually, get to rent out compute, get an SSH key, paste it in terminal, and then, getting a quick access that is not going to be, too much of a hurdle. And I would say the second thing is scalability, making sure that you have a system that is robust and scalable, because it's a great thing to actually open up to all of the nodes, but it needs to be functional, if you actually really want to be competing with the centralized cloud.
You've heard from me enough. If you want to add AI images or videos to your app, come up to me.
All right. Well, how about a warm round of applause for our panelists? Thank you for your time. We'll be right over here if you want to chat.